Let us solve a few problems on combination of simple harmonic motions. So the first question which we address is combine the two SHMs given by we go to the answer, but before that let us recall the general result. If x1 is a1 cos of omega t and x2 is a2 cos of omega t plus delta, then if we add them, these two SHMs having same frequency and collinear, then we get r cos omega t plus theta, where r is the amplitude of the resultant simple harmonic motion and has this value, and tan of theta was obtained to be with these formulae. We can solve problems like these. In this problem, a1 is 2, a2 is 2, and the problem we did was with cos, but here we have to replace cos by sine, and delta is pi by 3, which is 60 degrees. So we come to the answer. Where r is given by 2 square plus 2 square plus twice 2 into 2, as here cos of 60 degrees. This is half. So we have this to be 2 root 3, and the value of theta is tan inverse a2 sine delta, which is 2 sine of 60 degrees this gives us 30 degrees. Use calculator to get to the result. So the answer is the problem is in sine, so we have to write it in sine. And now let us draw a phasor diagram or phase diagram. This is omega t equal to 0 line, along which we have x1, the amplitude of which is 2. So this is 2, and x2 makes angle pi by 3, that is 60 degrees, the amplitude of which is 2. So the resultant is 2 root 3, and this angle, as we got, to be 30 degrees. Next problem, combine the two SHMs given by So these are of same frequency, but one is sine, one is cos. So let us bring them in step so that they can be compared. And sine omega t plus pi by 2 is cos. So in this problem we have a1 to be 3, a2 to be 4, delta is pi by 2, so the value of r is this is 0, so we have 5, and theta is tan inverse using this formula. So this gives us tan inverse of 4 by 3. Using calculator we can find it to be 53 degrees. So the answer is, that is the sum of these two SHMs is given by 5 sine omega t, the frequency has to be same, 53 degrees. And phase diagram, so this is omega t equal to 0 line, along which we have 3, and then we have to draw a 4 at 90 degrees, and then join them, and this is 5. This is pi by 2 as given, and this angle will be 53 degrees. So this is A1, this is A2, and this is R, and this is theta. Let us solve the next problem. Combine the two SHMs given by an x2 as so we note that in the two component SHMs the amplitudes are same, the frequencies are same, only the phases are different, rather the epochs are different, delta 1 and delta 2. And they are collinear. So the resultant displacement using principle of linear superposition is given by so let us take a common so combine them to get and now we'll have a negative sign. So here we have omega t cancelling this omega t, and we have delta 1 minus delta 2. So this term does not contain any t, but here we will have a t. Twice omega t by 2 is omega t. This can also be written slightly differently, considering the fact that cosine is an even function. So x is so this is the answer. Let us consider two cases. So case 1, suppose delta 2 minus delta 1 is 0 or 2 pi or 4 pi, etc. Let us take delta 2 minus delta 1 for simplicity and for illustration. So this means delta 1 and delta 2 are same. So if delta 2 and delta 1 are same, then we have here cos of 0, and cos 0 is 1, so A is twice A. So the amplitude is twice the individual amplitude, and therefore x can be written as since delta 1 and delta 2 are same, let us proceed with delta 1. So it is just, so this is the answer. For simplicity of writing, let us denote omega t plus delta 1 by say phi. So let us make a chart. x1 is therefore a cosine of phi, because this was x1, and since delta 1 and delta 2 are same, x2 will also have the same value. So this is equal to x2 also, and the value of x is twice a cos of phi. Now for phi equal to 0, cos 0 is 1, so x1 and x2 both are a, while x is twice a. For pi by 2, it is 0, cos pi by 2 is 0. Here we will have cos pi, which is minus a, and this gives minus twice a. Cos 3 pi by 2 is 0, and finally at 2 pi we come to this point again, the values of which are a and twice a. Let us make a plot. Here we will be plotting x1 as well as x2. This is a, and this is minus a, this is 0, this is 0, and here we will plot x. So this is a, and this is twice a, this is minus a, and this is minus twice a. In the abscissa we will be plotting phi, that is omega t plus delta 1. Now the value of phi is 0 here, say pi by 2 here, pi here. So let us write the values. Then here it is 3 pi by 2, and then here we have 2 pi. So we are plotting phi in the abscissa, and these are the limits a minus a, and here the limits are twice a and twice a. We'll now show the individual oscillations. At phi equal to 0, x1 and x2 was a, so the curve starts from here, while x was twice a. At pi by 2, both were 0. At pi, it was minus a, and here it was minus twice a. And then 3 pi by 2, and at 2 pi, a and twice a. So the oscillation is the difference between the individual oscillation and the resultant oscillation is amplification of amplitude. It is reinforcement or a doubling of amplitude. The conclusion which we arrive at is that the motion is in phase. There is a reinforcement amplitude doubles on superposition. A goes to twice A. We now move on to case 2, according to which delta 2 minus delta 1 is pi or 3 pi or 5 pi. They are the same points, and for simplicity and for illustration purpose, let us take delta 2 minus delta 1 equal to pi, or delta 1 minus delta 2 is pi, the same thing. So we can write delta 2 as delta 1 plus pi. Now since delta 2 minus delta 1 is pi, the amplitude of the resultant will involve cos of pi by 2, which is 0. So A is A is 0, and this means x is 0, because A is 0. Now let omega t plus delta 1 be equal to phi, and let us make a plot. Phi x1 is therefore a cos of phi. This is x1, and x2 is a cos omega t plus delta 2, and delta 2 is delta 1 plus pi, so it is a cos of phi plus pi, and the value of x is always 0, as we got. So let us investigate why it is so. So at phi equal to 0, x1 is a and x2 is Here we have cos pi, so minus will be there, it is minus a. And this is 0 always. Here it is 0, this is also 0. At pi, cos pi is minus 1, so it is minus a, but this is pi plus pi is 2 pi, and cos 2 pi is cos 0, that is 1, so x2 is a. At 3 pi by 2, both will be 0, and at 2 pi, this value is restored because it is SHM. If we add these two rows, we end up with this result. Let us draw to see the motions that lead to zero displacement always. So here we will plot x1, and here let us plot x2. This is 0, this is also 0, a minus a minus a. In the abscissa, we will plot phi. This is phi equal to 0. This is phi equal to pi by 2. This is pi. This is 3 pi by 2. And this is 2 pi. These are the limits of oscillation. Let's plot the points. At phi equal to 0, x1 was a, but x2 was minus a. At phi equal to pi by 2, all were 0. Then at pi, x1 was minus a, and x2 was plus a. And then at 3 pi by 2, all were 0. And finally, a minus a at 2 pi minus a. And let us connect the points to get the nature of oscillation. So it is very clear that x1 and x2 always oppose each other. They are inimical towards each other. And since one destroys each other's effect, when we add them, we will get x equal to 0. So we can show that also. So this is the resultant. This is the resultant. So let us conclude. Motion in antiphase they destroy each other. The amplitude, that is the resultant amplitude, is extinguished. It is 0. It is switched off on superposition.